The notes, we're going to take a lot of different dates, so the date doesn't really quite make as much sense as it does for a regular assignment, okay? And so we're going to take notes together most days. When you have a chapter test, you are going to turn your notes in to me along with your test, and you will get a score on the test, and then you'll also get a score for your notes based on how neat they are, how complete they are, whether you have any little smiley faces in there and things like that.
You like it when I do smiley faces?
Who doesn't like smiley faces? I mean, come on! All right, so we're going to start with section 1.1. And the first section is about evaluating algebraic expressions. All right, so let's start with an algebraic expression. The one that they have in the book is 30n. Okay? 30n is an algebraic expression. Can anybody tell me why? Anybody else? Alyssa?
Because it has a variable.
Because it has a variable in it. Okay, good. So this bad boy right there is called a variable. Okay? This number right here, since it's paired up with a variable, has a fancy name. That is called a coefficient. That is a big word. It's a coefficient. So the number in front of a variable is a coefficient, and anytime you have a new variable, if there's a number in front of it, you got yourself a new coefficient. Okay? And so then that makes this whole thing an algebraic expression. And, well, let's see how we'll get into that right now. We'll do that in a second. Another word for this, since this letter is called a variable, what's the difference between, what's the opposite of variable? Variable means change, right? What's the weather going to be like today? It's going to be variable. That means it's going to be sunny, cloudy, rainy, windy, who knows? It's going to change a lot. Okay? So what's the what's the opposite of something changing? Anybody know? Yes? Staying the same, okay? And so the fancy word for something staying the same is constant. Okay? So the number in that is also called the constant, because that's not going to change. The 30 is always going to stay as a 30. The n can be whatever we would like it to be, because we have that power. Okay? All right, so that makes sense? All right, and then I could throw some more stuff on here if I wanted to. I could make this plus 15x minus 37w if I wanted, and I still have a variable expression. What are my new variables? Yes? X and w. What are my new coefficients or constants? Hannah? What are the new coefficients or constants that I wrote on the board? Just name one of them. 15 is one, good, and Jordan, the other one is 37, not bad writing, okay? All right, and I could make as many of these as I want, and that would be awesome. All right, so what we are learning about today is we are learning about evaluating these expressions. And when we evaluate, we are plugging in or substituting a number for the variable. Okay? So when you evaluate an expression, you just take that variable and you plug in a number for it, and then figure out what the answer is with that number in there instead. So evaluating is the fancy math term. Substituting is also a fancy math term. Those are the ones that you are supposed to know. How are we doing so far? Have I done anything crazy? Are you totally confused? We all right? How many of you have seen most of these words before? Most of you, awesome. That's good. That's a good thing. All right, so let's do a couple of examples. So, for example, let's take x plus 5 and evaluate it for x equals 11. Do you have to show your work on this one? No, you can do it on your head, right? I take the 11, change the x to an 11, so now it reads, I'm going to show my work because I'm a teacher, I have to. So I change the x to an 11, so it goes from x plus 5 to 11 plus 5, and the answer is 16. Okay? So no big surprises there. Let's try another one a little bit trickier. 2a plus 3, or a equals 4. So when the number and the letter are right next to each other like they are in this problem, oh boy, all right, we got all kinds of things going on now. Wait, don't tell me. It's Ben. Go ahead. It would be multiplication. Good. So this means 2 times a plus 3. So if I change the a to a 4, then it is 2 times 4 plus 3. And Michael, what do you get from that? 11. Good, because as we talked about yesterday, your order of operations, you do the multiplication first. 2 times 4 is 8. And 8 plus 3 is 11. Yeah? All right, so now this is a little bit crazier. That is Senior Stearns on the other side of the wall putting up posters or something. Probably hard to see. Okay, so let's take this, 4 times 3 plus n minus 2, and now we're going to evaluate this for n equals 0, 1, and 2. How many answers am I going to have to this problem? 3. I'm going to have one answer when I plug 0 in for n, another answer when I plug 1 in for n, and another answer when I plug 2 in for n. Okay? So somebody from over here, tell me what you get when you plug 0 in for n. So Quentin or Michaela or Hannah, that'll work. Did you get? Nope, she's panicking. Alyssa, you got it? 10. Okay, so if I say n equals 0, then that means I'm going to change this to 4 times 3 plus 0 minus 2. What do I do first? Just say it inside the parentheses first. So 3 plus 0 is 3. What do I do next? You got it now. Whatever your name is, it is it's Tiffany Cray's sister, yeah. Brianna. No. You guys are mean. You guys are mean people. It is, yeah, it is Brianna. All right. You multiply. So 4 times 3 is 12, minus 2, and then we get a final answer of 10. Okay? So nice job there. All right, somebody from the middle 2 rows, get me, Kara, you got for n equals 1? What'd you come up with? 14 is correct. So if I rewrite this as 3 plus 1 instead of 0, again, what do I do first? Just say it. Parentheses. So I'm going to add 3 plus 1 is 4. 4 times 4 is 16. And 16 minus 2 is 14, which is what she said. And then finally, if I plug in 2, let's go with Ben. 18. Yep, that's going to work out. So same thing, start by replacing the n with a 2. What do I do first? Parentheses. And then if I multiply those together, I get 20. And 20 minus 2 is 18. Okay? So that's awesome, right? Most fun you've ever had? I hope not. All right, one more thing, and then I'll cut you loose. Why stop with one variable when there are so many letters in the alphabet? Yeah. You weren't done? Okay. We'll go back. We'll give you time to finish. I just got to get these two guys here. This is Jillian, and that is the ones that I did up there, or like what I said, you mean? You can just draw the words with the arrow, it's fine. All right, so then like I said, we don't need to stop with just one letter. We can use more than one if we would like. So if we have 5x plus 2y, let's plug in 13 for x and 11 for y. Okay, so this is some tricky stuff here. You can't what? I have bad writing, I'm sorry. Do I need, is it?
The 5 x something.
Oh, plus,
Oh, okay.
and then that's a y. So 5x plus 2y for x equals 13 and y equals 11. So first step is, yes? 5 times 13, good, because the x becomes a 13 plus 2 times 11. Okay? So I do my multiplication first. 5 times 13 is, you can just say it, 65. 2 times 11 is 22. Add those together and you get 87 as the final answer. Okay? All right, I think you guys get the idea, don't you?
Yeah. What's my name?
Finish off what's up?
What's my name?
Oh, it's really weird for you to be asking me that. How old are you? Like, how old
Never
are
mind.
you? You don't even know your own name? That's kind of, that's a bad deal. You got some issues, I think.
What room number is this?
412. All right, so let's do some homework. Oh, now it is Friday, right? Okay, so we'll go a little bit easy on you, just a little bit.
Wait, just a second.